Hey everyone, this is Hanney here again, twice in a row. Yesterday we had part one of God of the Gaps, covering the cosmological gap with Dr. Lawrence Krauss. And today I'm very thrilled to have somebody who I admired for so long, and I've used them as a reference to check on my science and to understand complex ideas in very brief time in few minutes. I would like to welcome my brand new friend, Dave. Hello, Dave. How are you?
Very good. How are you doing?
I'm doing fantastic. Thanks very much. Uh, we've been chatting offline, and I've been telling you how wonderful your channel is. And by the way, it's in the description of this video, guys. Please check Dave's YouTube channel. It's called Professor Dave Explains. And Dave, if you can start by telling us a little bit about this endeavor of yours.
Yeah, so in 2014, I just had an idea to start a YouTube channel. I thought maybe I could get some passive income going or something. And I started just by uploading organic chemistry tutorials. So I had just previously been teaching organic chemistry at this trade university for about 4 years. So I had my OChem lectures kind of nice and organized and worded just so. And so I put up about 40 OChem lectures, and people dug them and wanted more. So I did some general chemistry tutorials with animations, and then I did biochemistry, biology, astronomy, and it's just really ballooned out into this sort of all topics sort of place. I've begun hiring writers to expand into areas that I don't have any expertise in, and I'm really trying to cover. I'm both trying to cover every academic subject known to man, while fulfilling my personal goal of trying to become a great generalist, because I keep learning so much. I'm doing like immunology tutorials and economics tutorials and stuff, and it's all new territory for me. So I get to learn as I go, and just want to be a big hub for learning.
Well, very similar to my channel is actually mostly Arabic. So I'm an Egyptian Irish man who lives in Melbourne, Australia. We're the most locked down city in the world, on record now.
Wow.
We've surpassed Buenos Aires, so I think it's 285 days in lockdown. Crazy, but I think end of October we should be sort of free again to roam the street. We actually even have a curfew, Dave,
Wow.
after 9. Can't go on the streets after 9 p.m. So it's been
That would
very
not
tough.
fly in the States. I think you'd
I
have
know.
mutinies.
I know.
Yeah.
There would be riots.
Yeah, there would
for
be.
sure. Yeah, I'm very much similar. I'm trying to communicate, but to a particular area in the world. Some might know that the U.S. is quite unique, a country in the sort of the first world Western culture, where you can get pockets of cultures. The North is completely different than the South. The North might be just more open to science and technology, and you go to South, while you find wonderful things like generous food portions and welcoming people. But on the other hand, you have, it's renowned for being the Bible Belt for a reason. Where most of your audience come from? Are they sort of Northish, or you get them from everywhere around the U.S.?
Definitely everywhere around the States, and the States are really just about, I think, 30% or so of my viewership. I have a pretty wide international viewership as well, Asia and Europe, and I mean definitely like India and the Philippines, and then a lot of English-speaking countries like Australia and the UK, countries in the UK, but yeah, kind of everywhere, because it's just people everywhere are studying science and they need help, and so that's where they go. Some of them for some help. So
Yeah. So this is a 5-part series. One of the reasons in the background of these series is I'm not sure if you heard about Clubhouse. It's brand new phone application that started, and I think it's going to change the world forever, especially in countries like the Middle East. It's highly encrypted application where people open rooms. It's like Paltalk, the old days, sort of the old times, but now it's a lot more modern. You open a room and you can have a discussion, whether it's academic or even a casual chat. And taboos in the Middle East, like religion and politics and things like that, could be spoken about quite freely in this forum. And one of the things that I've seen is the amount of non-theists in the Middle East, and the huge amount of them, and the conversation that is ongoing between the faithful and the atheist communities in the Middle East, and the 5 things that keep coming, coming from the faithful camp, was science is just miserable. It can only get you to a certain degree. There are a lot of questions have never been answered, and therefore here lies my form of a god, because there's so many different forms and so many different religions. But here lies my god in that unanswered question. And there were 5 of them. I started with the very beginning, the cosmological gap. What happens before, or happened before the Big Bang, if the word before means anything. And then followed by today's episode. I've had that covered with Lawrence Krauss yesterday. And today, after the universe is formed and planet Earth, maybe even before planet Earth, because we could talk about panspermia, life emerged. And a lot of people who discuss evolution, they keep conflating evolution and the topic of today, which is abiogenesis. If you can take us through the differences, please.
Well, so abiogenesis is the origin of life from non-living material. There are aspects of evolution to it, as we're starting to understand that systems of molecules can undergo something resembling Darwinian evolution. But usually when people are talking about evolution, they're talking about the ways that living organisms change over time. So we're presuming that life already exists. So I would imagine that that's probably what you'll be talking about tomorrow with somebody. But what are the 4th and 5th? Because I can't even imagine. Really, the first 2 are the only ones that I think have even an ounce of validity to them.
So the other 2 things is the emergence of consciousness, and it's more into neurology and philosophy. That they call it the hard problem. We have a philosopher in Australia called David Chalmers, called the hard problem of consciousness.
Yeah.
And this is where you get the simulation hypothesis and everything interesting. And the 4th is the sources of morality. Where do they come from? Are they objective or subjective? And why do we have those moral urges if there's no God? And the 5th one, and the final one, it's the most important one when it comes down to it, because nobody cares about science if they sort of fighting for their life. What happens to us after we die? And obviously, religion has a ready answer for that.
Always has.
Always
has. Yeah, it's very interesting to me. I mean, you would think that anyone with some knowledge about the history of science over the past few centuries would understand that a God of the gaps argument for the existence of a deity is a very, very bad one, and should be avoided at all costs. But here we are, and to me, I mean, I suppose it's hard for me to imagine those other few as any kind of grounds for God of the gaps. I think certainly the first 2 to an extent, but I hope you got through some of it yesterday regarding the beginning of the universe. I think that's probably the last one that will remain for another few centuries. But as far as I'm concerned with abiogenesis, it's just not really. It's to people in the field, it's not outrageous. It's not that crazy that life can come about from non-living matter. It's about certainly elucidating the pathways by which it could have happened with more and more rigor. But it's just the more you understand about chemistry and biochemistry and physics in these fields, the less absurd it becomes, almost to the point where I am of the frame of mind that I believe that life is probably very abundant in the universe, at least very rudimentary, probably, unicellular life is probably everywhere. It may even be in other places in our solar system, right? We may find it on Europa or Enceladus, or, maybe even Mars way deep down, or, who knows? But, advanced intelligent life, probably, comparably a lot more rare. By what amount, who knows, by what proportion, who's to say? But once you begin to really dig into it and learn about it, it's not that crazy. So
Yeah. Well, I mean, yesterday we covered not just the what happened before the Big Bang, but also the fine tuning issue, because that's a second situation where everything seems to be fine tuned. So there must be a designer, and we've addressed that as well. That things are, it's a back to front argument, because we can only exist in the world that we can exist in, not the other way
That's right.
around.
Yeah.
Yeah. So you evolve according to your habitats, and that habitat does
Right.
not give consciously rise to you. It's just
Here we are saying, wow, look how convenient it is. We need water, and there's water everywhere. We need oxygen to breathe, and that's everywhere. Meanwhile, there's some organism in another galaxy saying, wow, look at this. There's ammonia everywhere, and I need this ammonia, and I breathe sulfur dioxide, and that's everywhere too. It's like, it's exactly as you were saying, but the same principle applies, certainly, and even more comprehensively, I think, to living systems. Yeah.
Yes. Yeah. So the area, when let's now delve deep into the abiogenesis situation, and this is quite interesting, because the history of this movement, and it's mostly around in the U.S., started with the Creationists and the monkey trials. The famous Inherit the Wind movie with Jack Lemmon, and I think there were a couple of other versions of it. And the situation where there is a notion that, oh, this is way too complex. This is just, it's not enough time for this to happen. I've never seen a piece of rock turn into a living being over time, or it never does. And hence the word spirit or soul, to be given to something, to give it that animation, to make it from inanimate to an animate thing, and the spirit of things. But we kind of know these days that this is a byproduct. It's not a thing that is being put inside of you. It's an emerging property, just like molecule can be far apart or very put together, and that would give you warmth or cold. The property of something being cold or hot, temperature, is a byproduct of how the density of molecules and how they sort of gather together, whether they're dense or far apart, and how they active they are.
Or the speed, average molecular velocity. Yeah. But
Yeah.
to speak to what you're saying, I mean, this argument also baffles me because complexity is not the hallmark of design. Simplicity is the hallmark of design. So if you had a living organism that operates essentially like an iPad, well, that would point me towards design. But the fact is, it's a mess in there. It's extremely complicated. There are things that there are biosynthetic pathways that take so many enzymes to do these very minuscule changes on a substrate. That to me shouts randomness. That does not appear like design to me. But then after that, you were talking about sort of the emergent properties, and this goes back to like more than 150 years ago. Friedrich Wöhler, I think his name was.
Mm-hmm.
So vitalism. This was a philosophy that living systems had some kind of vitality bestowed upon them, clearly by a divine creator, and that the substances within living organisms were other. They were not. We did not have access to them. We could not create them or forge them, and he dispelled that by synthesizing a molecule called urea. It's a very simple molecule. It's about less than 10 atoms in it. But so instantly, we're talking about the beginning of the 19th century. We're dispelling the notion that there's something particularly vital or other in living systems. It's just molecules, right? It's just molecules in here. It's amazing how people don't seem to have gotten that memo, because we're seeing that come up even these days about synthetic versus natural, right? A molecule like a vitamin or something, where you have a natural counterpart and a synthetic counterpart. People will presume that the synthetic must be lacking in some kind of vitality just because humans went in there and synthesized it. That's categorically false, right? The properties of a molecule depend on its composition, what atoms are in there, and the shape of the molecule. That's it. So it doesn't matter how those atoms came together. So this isn't necessarily, this is sort of a precursor, I think, to abiogenesis, but definitely continue on that thread where you were going with that.
Yeah. So, I mean, and you have one of your followers in the chat here, Erwin Schrödinger, and we were talking about Schrödinger just offline, and I'm a big fan of his definition. We're talking about a physicist, one of the great ones of quantum mechanics, that he's talking about life, and its complexity is always there. You know, the ID groups have always paraded complexity of all sorts as a brick wall against all sort of ideas of how things could have evolved. But Edmund Schrödinger's, where he was trying to define life, he said life didn't have to be that complex. All what you're seeing right now is, and what you're defining life to be right now, is what you're seeing is after things have evolved for many epochs. But life, when it started and emerged from chemical sort of mixing up of molecules and bits and pieces, it didn't have to be that complex. All what it had to do is to resist entropy to start with, and very small things, and then it can build up upon that. I think there are actually organisms that we know about right now that sort of roams the ocean, and it doesn't have any senses other than speed. I think it slows down when there is food, and it just passes by in a certain sort of speed, consistent speed when there isn't, and just a change of movement.
Yeah. So chemotaxis,
Yes.
phototaxis. Yeah.
Yeah.
It's tempting to look at very simple multicellular organisms and ascribe them with some kind of sentience, but it really, when you look at a living organism that's that simple, it really is chemical reactions. Like, we know the chemical reaction, we know, we can describe them, but really that's way too complex already. When we're talking about the origin of life, obviously we're talking about unicellular organisms, and the point is that we're talking about something dramatically simpler, like the most common straw man, or one of the most common straw men for creationists put forward, is they will show these dazzling animations of the components of modern eukaryotic cells. So these are the cells in animals and plants, and obviously there's a lot going on in there. But eukaryotic cells they didn't evolve for 1 billion years after the first prokaryotic cell. So for anyone listening, quick bio lesson, right? You've got prokaryotic organisms, which are unicellular, one cell, and that would be like bacteria. And then you've got eukaryotic organisms where the cells are much more complicated. They have organelles and there's a nucleus and everything. So looking at anything eukaryotic is an instant straw man, because once prokaryotic life arose, it was literally 1 billion years before eukaryotic life arose. So there's a tremendous amount of evolution going on there. But even looking at modern prokaryotic cells is still a straw man. Bacteria had been evolving for billions of years, just like everything else. They didn't, they remain prokaryotic, so they're comparatively much simpler. But still, the very first a system of molecules that could be considered a living organism, certainly it's a big gray area, so we'd have a hard time defining it, is still incomparably simpler than any bacterium that you could find today. So I think that's the main block here, is that when people think of life, they think about things that are around today, and first of all, they may not even know the difference between bacteria or plants or anything like that. But much more subtle is the difference between the simplest organism today and that which arose 3.5 billion, 4 billion years ago. So to understand that difference, you need some knowledge of biochemistry, chemistry, that sort of stuff. So that's a big roadblock, I think, for most.
Yeah. So no, I get that completely. Even the components, the initial building blocks. So we're talking about lipids, proteins, and obviously prior to the DNA, the RNA, which I think there is a hypothesis within the abiogenesis theory that talks about RNA being the precursor because it's simpler, just the one helix, and also can act as a protein, so it can do both functions.
So it's pretty universally accepted amongst origin of life researchers that we're looking at an RNA first world. In fact, it's extremely probable that life arose prior to the emergence of DNA. I think that most would conclude that life arose and then DNA evolved to replace. It was a better system, so it was adopted after the fact. But yes, as you said, RNA is much simpler, but also we have come to understand that RNA can have enzymatic capabilities. We call them ribozymes. So usually when we're talking about enzymes, which are molecules that have some catalytic function, they do chemistry. We're talking about proteins, but actually RNA molecules can also be enzymes. So we call them ribozymes. And so there's this whole field of systems chemistry that's looking at molecules like ribozymes and peptides and the autocatalytic behavior that emerges. And so you've got RNA molecules that can catalyze the synthesis of, first of all, themselves. So that's where the first instance of self-replication arose. And they can also catalyze the synthesis of other molecules like peptides. So obviously, I'm dramatically oversimplifying it, partially because I'm not an expert in systems chemistry to begin with. But once you have systems of molecules that are synthesizing themselves and other molecules, the others being peptides, and then proteins obviously have their wide array of catalytic functions, then it really becomes not that big a pill to swallow that these systems of molecules would refine over time through some kind of selective pressure to then produce eventually over millions of years something that we might call a living system.
Yes. And we know that you've talked about life could be in abundance in a universe. We know that the building blocks of life are actually like lipids and basic amino acids actually are abundant in space. And I think we're in Australia in 1972 or something, there's a meteor that sort of fallen on Australia, and it had many of these building blocks, as well as the famous 50s experiment where that primordial soup, where
Murchison meteorite, Miller-Urey. I mean, so yeah, these things, these early experiments, as well as modern spectroscopic data, it's very clear that the very basic biomolecules are abundant. So even as complex as amino acids, and then obviously formaldehyde and other building blocks that are going to get you to monomeric sugars and things like that. So that's no problem. We can assume that the basic building blocks are everywhere. Obviously, that's nowhere near the finish line. We still have a lot to work out in the way of those molecules polymerizing, and then those systems of molecules complexifying. But the building blocks are there. We see them, as you said, we see them in space. So that part's no problem. Yeah.
And one thing that obviously, when you come from a religious background, you have the typical story, Adam, and then Adam and Eve, and then the rest of the world. And basic biology would tell us there are a couple of concepts with minimum founding population and minimum viable population. When we talk about LUCA, we're not talking about a single cell that is emergent and is the common ancestor of everything that is living today. We're talking mostly about population in different areas. There are so many different trials in different areas, probably around water. Seems to be one of the ingredients needed for life. And it's been happening all over, with the lightning zapping the water. And it's most likely a population, not a single cell, right?
Honestly, that's a very good question, and I don't know that anyone really knows with certainty, because the thing is, yes, the conditions for the first living organism to arise would have been present for millions of years. But the thing is, once that first cell emerges that is capable of self-replication, efficient self-replication, it may be the case that just dominates the landscape, and we really literally do have one organism that is the ancestor of everything alive on Earth. I don't know. I mean, or as you say, it could be something over here and something over here, and then but it's not insane to think that it could literally be one cell, and then as that replicated tremendously, then that's where you begin to have variation, and you have had different, you have different iterations of that cell, and then this one by chance develops some kind of novel metabolic process. And so then that becomes more finely tuned for this region here. But I mean, you know, you give a population of cells 1 million years, it'll cover the world, it'll cover the earth, you know. So I think that's honestly the main, if I had to pick one straw man that that I really wish creationists would drop, is that they think that in order to substantiate abiogenesis as a feasible process, scientists need to create life in the lab. Right. This is a major, major misconception, because their notion that if life can arise from molecules, that we should be able to take molecules and go, okay, this one here, boom, 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 there you go, it's alive. Well, that's not possible. And nature also didn't do that, right? We have systems of molecules enclosed in vesicles complexifying over millions of years, right? So I think that, you know, if there was some ability to get an understanding of rudimentary systems chemistry and get that across, we might be able to get past this straw man. Because synthetic biology, as fascinating a field as it is not really related to origin of life research. It's a separate field, right? And we may one day synthesize some rudimentary form of life, right? Origin of life researchers are not trying to do that. They're trying to elucidate the pathways by which life arose billions of years ago. They're not trying to invent some new kind of life. That will be amazing and remarkable if and when we can do that. But of course, you know what the creationists will do. They'll just say, haha, see, you need intelligence, right? So we'll just be back to square one with them there. But truly, I wish that everyone could understand that the amount of time, right? It took millions of years for these systems of molecules to stumble upon the sequences of monomers in RNA and in polypeptides to produce these sets of molecules that were capable of metabolism, of self-replication, of all these things, right? Because it is truly random, right? And there are all these possible sequences of RNA, of ribonucleotides, of amino acids, and it took a really, really long time to get to these interesting sequences, you know.
But even with that, we're talking the Earth is about 4.5, 4.6 billion years old. The first 700 million years is just a boiling pot of everything, probably preparing life, because that you probably needed that as a precursor for life. But then 3.7 billion years is not enough for the likes of Michael Behe and William Dembski, because they think the complex cell, 3.7 billion years isn't near enough for it to emerge. I think personally it might be enough, but then who says that it had to just emerge on Earth? I mean, we're talking about a universe that is 13.8 billion years. We know that life forms can travel in different shapes of form, like we talked about this meteor in Australia. It could possibly be in an older existence before Earth. The building blocks have already came pre-prepared from outer space, and then the finishes touches took place on Earth. Could that be possible?
It's certainly possible. It's certainly physically possible. There's no evidence to indicate that. And I mean, as creationists, even they correctly point out, it doesn't really solve the problem of abiogenesis. You're just pushing it to some other world, it had to form there first. Sure, it's entirely possible that whether rudimentary biomolecules or even the first, very basic unicellular life could have been delivered here on meteorites. But I don't think that it's necessarily something that the origin of life research community is really focused on. I think that they're more focusing, because the thing is, we have plenty here, right? You've got a very hot early Earth. It finally cools down, and we're in a temperature range where all this kind of chemistry, it's still hot, warm enough for this chemistry to be possible, but not so hot that everything just instantly degrades. We kind of have everything we need right here. We have, I think the leading hypothesis within the community is sort of steering towards hot springs. So other hypotheses have been like volcanic vents way deep in the ocean. tidal pools, mineral tidal pools, which are still perfectly viable. But I think a lot of the research is shifting over towards hot springs and sort of this wet, dry cycling. So you have chemistry occurring, and then you have evaporations, and then you have precipitation and evaporations, precipitation. You have all of these cycles. You have a day-night cycle, right, where you're getting a little hotter and a little colder. You have lunar cycles. You have things like that. We honestly have everything we need here to solve these problems. Does that mean for sure that it didn't come from somewhere else? I mean, I don't know. I don't know that we'll ever know that. But I think to origin of life researchers, the goal is to elucidate the pathways by which it is viable to get from these monomers to the polymers to rudimentary life. So that's what they're focused on, from what I can tell.
Even Charles Darwin, when he sort of was envisaging how this could have taken place, and I think he mentioned that sort of muddy, warm lake bubbling away, and the thermal vents, and possibly, and he said you don't need much, you need just 3 or 4 simple ingredients to start the process. So it's not that. But I mean, we're talking about 3 centuries ago. So
a little more than that, but yes, Darwin had. How could he have had any knowledge of molecular biology? So yeah, he was doing the best he could. But in the end, the spirit of what he was saying, there was some truth to that. Yeah, right. Absolutely.
Yeah. Just like Democritus is talking about an atom. He never. Yeah, but he got the idea right. There's an
philosophical conjecture.
Part.
Well, but that part he got so you could go into a lot there, right? Because obviously, when we found atoms, we named them atoms in his spirit because he named them atomos. But then very quickly, within a couple decades, found out that they are not indivisible; that they contain subatomic particles. So but the idea that a substance is made of tiny, tiny little particles that all have the same properties for that substance. Yeah. I mean, the Greeks, they're some smart ones in there.
Quarks should be called atoms now.
Maybe. Yeah. It's too late now, though. Atoms are atoms. We're stuck with it.
Exactly.
Yeah.
So this is an interesting conversation, because it's going to take us inevitably, even though we're trying to avoid talking about evolution because people conflate the two, but you can't help but still talk about evolution, because even the abiogenesis of things takes some evolutionary steps. So, for example, when you talked about the first cell, and that's why I said the minimal founding population will still have to be in effect, because things like a virus is not characterized as a living thing for different reasons, but it depends on your definition of a living being. I think Edwin Schrödinger would have included viruses as a living thing, according to his simple living things. And we know that some viruses can actually attack bacteria.
And well, of course,
and they can actually they get bacterial disease by viruses. So the minimal viable, the even at the emergence of the very first few cells, they will be subject to evolution straight away as soon as they've emerged, and most probably they will have to adapt and to survive the pressures around them, and they could end up being sort of demolished or not survive if they don't have the right adaptive mechanism to help them survive. So I'm leaning towards the population still for the initial state.
Right. So yeah, virus. I mean, the reason we don't consider viruses to be alive is because they do not. They're inert. Right. So living systems are dynamic systems. There's chemistry, even in a unicellular organism. There's just a lot of chemistry going on. There's metabolism going on. There are a lot of chemical reactions happening at all times. And a virus does not do that. It's just a little sack of genetic material. So I think most microbiologists would agree that viruses emerged well after the origin, well after cell-based life emerged. But to go back to what you're saying, I mean, more of what it is with sort of Darwinian evolutionary principles applying to systems of molecules. And this is another straw man that I think is put out there, is when people, it's just that we use the word selection, and humans are capable of selecting things. So we attribute sentience to the process of selection. It's just an unfortunate byproduct of using that word, because really we're just talking about statistical dynamics. So when people say there's nothing to do any selecting or anything like that, all we're talking about is whether you're talking about biological organisms or if you're talking about systems of molecules. And let's talk about the latter because we're talking about abiogenesis. If you have a system of molecules, we're talking about RNA, we've got ribozymes, we've got polypeptides. If you have this system of molecules and it is slightly better able to self-replicate, then that system of molecules is going to perpetuate with a greater statistical significance. It's just statistics, right? If you have things that are trying to replicate and one does it better, you'll have more of those, right? It's really just basic logic. And so when you have something that is self-perpetuating with greater efficiency, it is going to dominate the landscape, the biological landscape. And so that's really, I mean, this is relatively new, right? We did not know much about systems chemistry. This is really a 21st century, it's a 21st century field where this emerged. And if you're interested in learning more, Gerald Joyce, I think, is probably the guy who has done the most in this regard, looking at ribozymes and physically demonstrating competition between ribozymes for a common pool of substrates, right? You've got different ribozymes trying to self-replicate, and they're competing. There's a limited amount of substrate to utilize, and you will see, or he even calls them quasi-species, right? They're not literally species, obviously, but they're different ones, and some are better at it, and then they proliferate with greater statistical significance. So they're selected for, right? And so this is something that we're starting to really understand, particularly in the past decade or so, that this is absolutely critical to the emergence of life. So if you want to divide it up, certainly you can talk about the pathways to get to RNA and proteins and things like that, to get to these first biopolymers. But then from there, systems chemistry is the whole show, where we're talking about how these can quite literally evolve over time to become systems of molecules that resemble something that we would call a living organism.
Right.
So.
There's something akin of cosmology going here in biology as well. You know, in physics, you have the special relativity where things are happening in a vacuum, and it cannot be generalized. So you got to have certain conditions for it to happen that way, and not having any external pressures on that system like gravity and such things. That's why special relativity is special and works only in certain conditions. And when you think about it, in biology, there's something akin to that. Reptilian life formed 65 million years ago. The dinosaurs were absolutely triumphant. They were so powerful and so successful. But then you have an external event that happens. And the weakest of things that they were hiding from all these mighty creatures happen to have the thing that will make them. We are the the children of these little shrews.
Our little rodent-like ancestors. Yes, absolutely.
Yeah. So it's because the system is so dynamic, anything can change. And what used to be a weakness of some sort one day could end up being a point of strength when an external power is a force working on you, and then it changes everything. So life is a very complex thing, and it's so dynamic. There's so many things that's happening around you, and we don't know. Nobody's guaranteed a spot.
Sure. Yeah. And I mean, with abiogenesis, it doesn't even necessarily enter, because we're talking about, right? We're not talking about like animals. Animal life is exceedingly complex and relies on many different factors of the environment, right? We need water, we need oxygen, we need all of these things. Whereas abiogenesis, I mean, you've just got these systems of molecules, and they're just making do with whatever chemical processes they stumble upon. And then also we want to bear in mind that the discrepancy in time scale for molecules versus an organism, right? A chemical reaction occurs on the order of picoseconds. We're talking about a trillionths of a second. So time, from the perspective of a molecule, if you can conceive of such a thing, is a trillion times longer. So when molecules had 500 million years to become a living system. Multiply that by 1 trillion. That's what we're really talking about. These molecules do things very, very, very quickly. Whereas macroscopic living systems, we conceive of time on the order of seconds, right? And 1 full second, which is an instant to us, is an eternity to molecule or a set of molecules, you know. So
yeah. Well, even my conversation with Lawrence Krauss yielded that time is a tricky thing.
yeah.
Maybe it doesn't even exist in the way we think it exists. You know, the universe does not see time. The present, future, and past sort of are uniform in the eyes of the universe. And things with quantum mechanics, with retrocausality, puts a lot of question marks on the concept of time itself. It's insane. But there are a couple of events in the, you know, there's the abiogenesis of where life has come from and how can inanimate things turn into being animate and living things. And the other second event that a lot of the faithful will still think it's a meaningful event, which is the genesis of man. If you notice, Charles Darwin avoided talking about the evolution of human beings for quite a while. He wanted to wise man, actually, and he actually held up to the whole of evolution theory for like 20 years or so, until Wallace told him he's about to release, and then so I've got to release my book.
Yeah, he got beat to the punch by a year or so, I think.
Yeah. But that's another event, because they will keep, you know, remember that Richard Dawkins' very famous conversation with that creationist lady, show me the evidence, and Richard Dawkins telling her it's in the museums everywhere, all the transitional species are there. There's still the debate going on about where does man come from.
I mean, it's at a certain point you're just battling against willful ignorance, because, you know, people, you know, they want to say evolution doesn't make any predictions. Well, look, you know, if you look at some extant species, we're identifying a lot of transitional species that must exist. Then we go look and we find them, right? Here are transitional species that are that are filling all of the gaps. And there are so many if you actually go and look. And we have the internet now, so you really can't hide from this stuff. You can literally Google list of transitional species, and you'll get a big thing with all of the references and all of the journal articles that you can go look at, where we're talking about from land mammals to whales, and the like 50 species in between, and from early aquatic life to early terrestrial life, and from dinosaurs to birds, and like all this stuff. And it's not like, I think that there's a tendency with creationists to kind of like hide under the coats a little bit and pretend that this information is not out there, that these discoveries aren't out there. But, you know, as you're saying, that Dawkins said, go to the museum. It's there. It's all there. Like, we can't help if you're hiding from it. What am I gonna, you know, I can't.
But you know, Dave, it's also it obviously also what you mean by transitional species, because the expectation out there is they want to find that being that is half monkey, half man,
right?
Which is that's not how it works,
right? The crocoduck, right? What's his name from Growing Pains or whatever? That guy's so ridiculous. But it's like, if you want to call it half, fine, call it half. But what do you mean? You mean literally morphologically identical from the waist down to one species and waist up to the top to the other species? What sense does that make? I mean, are you joking? Like, are you trying to, like, is this a literal joke? Like, I don't understand how any human brain would think like that. Like, if you want to say half one, half the other, yeah, you can find them morphologically intermediate in all respects. You can go from limbs that walk on Earth slowly becoming fins, or vice versa. And the ironic thing is, there are even extant species, right? Normally we're talking about things in the fossil record, but they're so ignorant towards zoology as well, that they're not aware that there are literally walking fish and flying fish. Right, there's walking fish. You can go on YouTube right now and put in walking fish. It's a fish that kind of like walks a little bit. Like, it lives now today, you know. So,
yeah, I don't know if you noticed my the logo of my channel. It has that Darwin
fish. I see. Yeah. Okay, cool. There you go. So you're ahead of the game already. But I mean, this is, that we're talking about extant species. And so that's obviously talking about 0.001% of all the species that have ever existed. So, I mean, you want to know what was there, go look at it. I mean, now we've devolved entirely into evolution, but I'm happy to go whichever way.
It is very difficult. You're going to have to touch on it because that abiogenesis we're talking about, the spark, is like, it's almost like the Big Bang. You can talk about it for a bit. You're going to move on because you cannot dwell on there. You want to dwell on there because you get the challenges coming from the other camp saying, well, I'm not convinced. It's impossible for this to happen that way. They can't. It's essentially an argument from personal incredulity. They cannot understand and conceive of how it must have happened. Then it must have not happened.
Yeah, and in fact, I mean, if you go back 500 years. Yeah, abiogenesis is a pretty big pill to swallow. I mean, we had no clue how that could possibly have happened, and I would not hold it against somebody living in the 16th century or 17th century that they were in disbelief that abiogenesis could be possible. But we don't live then. We live in the 21st century, and there's a lot of people doing this research that have a very firm grasp on how it certainly could have gone, and it's sophisticated knowledge, to say the least. So I remain sympathetic to those who do not possess the knowledge base to comprehend it. That's fair. But when you move from I don't get it to I don't get it, therefore it's wrong, that's just blanket science denial. And there's no room in society for science denial. It's just going to get us in trouble and ruin everything. So.
Right. This area in sort of biology, chemistry, it is to me one of the most dangerous, because even with cosmology, being a theist or non-theist, there'll be very little debate about cosmological events or bits and pieces. There just to be that sort of understanding. But within the biology movement, you get established scientists, and this is where the danger is. They carried over from the Creationists, having lost so many low cases in the US. I think 5 of them, including a recent one where a lot of people who sort of witnessed it on the case were actually Christian people who were biologists and actually said that intelligent design is a religious movement masquerading as science. And it's actually, if you go to Google, intelligent design, between brackets, the very first sentence, pseudoscience, because it doesn't give you the alternative scenario. All what it says, evolution is wrong. That's not a scientific theory.
Yeah. I've noticed a strong movement over the past, I'm not sure how long, a decade or maybe longer, of a shift in the creationist community from trying to speak in a scriptural way to trying to masquerade as real science. And so that's why, when they have so few real scientists among their ranks, but when they get one, they really, really prop them up as like, this is the best guy in this whole field, and look at what he says, so he must be right, So I find it all quite humorous, but it can be pretty convincing, because when you have somebody who on paper has their accolades, right, has their resume together, and then you have an audience that just really wants them to be right, all they have to do is speak confidently using jargon that nobody's going to understand, and they'll just. Yeah. Most brilliant guy in the field. He's so right. I love that you're here enlightening everybody. It's like the guy's lying through his teeth. Everything he's saying is a lie.
We also both know this is not how science works, because if this is the case, Einstein would have won the quantum mechanics argument a long time ago, but he didn't. And he actually had to apologize at some point, even though he still never liked quantum mechanics. He actually... there's a bit of misinformation there, because a lot of people think he never understood it. Einstein is one of the founders of quantum mechanics. He discovered, he just did not accept certain areas. He thought that, yes, but there must be a different reason than what you guys think. That indeterminacy is what you think, it's incorrect. But he understood probably quantum mechanics better than most around his time.
Of course he did. Yeah.
Yeah.
I mean, you're talking about giants in their field operating in good faith, having scientific debates about the nature of physics. And that's to be expected. But then, other people say, well, look at what happened in physics. And so that's what's going on here. No, it's not. You have science and you have science deniers. And that's why the science deniers, right, in the case of evolution, abiogenesis, and things like that, where are they preaching? Right? They're preaching in churches and they're preaching on YouTube. These deniers, where, of course, it's very predictable. You say, well, why don't you publish these critiques in reputable journals? And of course they can't, because it's not science. But then they'll say, oh, it's a big conspiracy and the corruption of big science, and they don't want to let us with our God science in there. It's just whatever you got to say to keep them on the leash, but I do notice that that's the way the movement has gone as of late, is to try their darndest to seem scientific.
Yeah.
There's
I think there's a Discovery Institute, Stephen C. Meyer, Michael Behe, William Dembski, who's obviously a computer scientist and a mathematician, whose theory about irreducible complexity or reducible specificity. Irreducible complexity is Michael Behe, another biologist, completely been thrown. Is unsubstantiated according to the scientific world. But also, I think there was a Netflix series about those scientists who are sort of been sent packing because they believe in an intelligent designer, and there is that particular cahoot around the scientific world to dismiss anyone who's got a different idea than evolution as if it's a
conspiracy. Of course. Well, because what else are they going to say? They're universally rejected by the scientific community. So, it's either I'm an idiot and wrong, or there's a conspiracy against me. Which one are you going to go with? But I mean, to me, it's like, look, I mean, it's obvious to us because we're not in that world. But if you're getting sucked in by this, okay, yeah, they have degrees. All of them are creationists. All of them are Christian creationists. It's not like there's some guy that's like, yeah, I'm an atheist and that guy's right. There's nobody is agreeing with them that's not on Team Jesus. You know what I mean? It's exclusively Team Jesus. They found the handful that have degrees and have actually, but honestly, some of them don't. Like, I don't know, there's the physicist that went on James Tours's thing, and it's like, this guy's never published any research. He got a PhD. I mean, I'll give him that. He got a PhD. He's not an idiot, but he's never published any research. He got the degree so that he could do this, so that he could say, look at me, I have a PhD, I must be right. Blah, 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 blah. All this science is not real. You know what I mean? It's just, they're enlisting soldiers in this little battle against science, which they perceive as threatening to their theistic worldview.
Well, we have, obviously my background is I'm an ex-Muslim, so we have something very, very similar, especially around Saudi Arabia. Saudi Arabia in the 70s and the 80s have started a campaign parading science in the Quran, and they start paying off a lot of scientists around the world. I think a couple of Japanese, a couple of Canadians, to prove that for example, the embryology in the Quran is correct and according to scientific, the most recent discoveries, and start buying these sort of scientific voices that will give sort of credibility to their message. And I think the same thing is happening with intelligent design. But I know that you've recently had a close encounter with James Tour, who's one of the proponents of intelligent design. Tell us a little bit about this and the background and how it emerged.
Well, he pretends he's not a proponent of intelligent design, which is funny because on his website he literally states that he believes the Adam and Eve myths. It's like, how is that not intelligent design? He just knows that you're branded as anti-science if you say that. So he just pretends. He just says, "Oh no, I don't know," But what happened there? I just I kept getting sent this one video of him kind of like shouting and we abiogenesis. I should know. I'm an organic chemist, so I know the most about this, even though he knows nothing about astrochemistry, geochemistry, systems chemistry, all the fields that are actually really pertinent to origin of life research.
Is he an organic chemist or synthetic chemist?
He's a synthetic organic chemist. So organic just means carbon-based molecules, and synthetic means you build them. So, surprising to some, synthetic organic chemist is not an oxymoron. It's a thing. And coincidentally, this is actually also what I was studying. Now, I wasn't. He's good. He's a good chemist. I was not. I didn't even finish the advanced degree. But it's also what I studied. And so I have somewhat of an elevated ability to comprehend origin of life research, though I'm far from an expert. But as it turns out, James also does not really know much about the field because he's hiding from it. He has the intellectual capacity to comprehend the field. But instead of looking into systems chemistry and things like that, he just shouts, "There's no selection with molecules," and just like basically discredits an entire field of science that he's never looked into. But anyway, I kept getting sent this video because he started to become very popular amongst creationists, because here's this guy with a good CV. You know, he's a good chemist. And he's saying all this stuff, and I should know the most, right? These people are all morons. They don't know what they're doing. I looked at it and I was like, all right, this is ridiculous. What he's saying is blatantly false. And nobody is challenging this guy. I looked on YouTube. I was like, debunk James Tour. Nobody's confronting this guy. Well, somebody's got to do it. So I guess I'll do it. So I made a 45-minute video, honestly, not even thinking he'd notice or care. Just sort of like taking some of his, just from that one video, he says some things, and I'm like, that's not true. Here's why. And by the way, here's why he's saying these things. He's super, super Jesus guy. And he, because I think it was probably the Discovery Institute that egged him on, because he's their little golden child over there. It got I don't know, like 200,000 views or something. And so they're like, you got to do something about this guy. And he made a 14-part series about how dumb I am. It was the whole thing. Oh, Dave is clueless, blah, blah, blah. Dunning-Kruger, while creating this series that is worthy of the Dunning-Kruger Hall of Fame. It's just, I was shocked. I was actually shocked at how ridiculous it was. So I just, I don't like that. I'm a bit vindictive. So I took his 10-part series. I spent way too long. I'll never get those 3 weeks of my life back, but I had to do it because nobody's challenging this guy. And I went through all of it. He misquotes so many researchers, uses countless straw men, just lies through his teeth, misrepresents what I said. So that part I could get through. And then I also reached out to a number of origin of life researchers, actually the top ones, some of the ones that we've been discussing and others, and personally corresponded with them. And only a small handful of them agreed to be visible in the response, to actually give statements and things like that. Most of them were just like, yeah, that guy's a nutbag. I don't want to have anything to do with it, but like, I'll send me what you're going to do and I'll advise you. So like I had a script and I sent it and they're like, this is great. This part's not quite right. Redo that. Or this part's really good. You want to use this paper though, because this paper demonstrates best what you're saying right there. So I had a little bit of help, and actually, I'm happy about it because I learned so much about origin of life research, because I really had to dig into it. I just split it into 2 videos. It was a 2.5-hour response where I really went into all of this, the nitty gritty, the physics and the geochemistry and the astrochemistry and the systems chemistry, which, like James prior, I didn't really know much about either. The only difference is I really want to learn about it. He's dead set on pretending the field doesn't exist. So I learned all about that, and I put those out. I don't remember, a few months, 4 or 5 months ago at this point. They're actually getting pretty good amount of views. They each have several 100,000 views. He went silent for a while. I just noticed the other day that he's back to his old tricks and putting out videos about the interactome and things like, and it's just, I don't know. I think I knocked him on his ass for a few months, and he's probably pretty ashamed. But his audience doesn't really care. The overwhelming majority of them did not watch my response and never will, because their willful ignorance involves a willful aspect.
Yes.
So they'll never watch that. They'll never watch that to find out exactly how duplicitous he is. But he's quietly resuming his activity over there. So I don't know, whatever. I mean, my stuff's on YouTube for all to see. If anyone wants to really see what he is and exactly what this guy is, that's there for everyone to see. But
the description of your channel, Dave, is a brilliant one in the video here, and I've watched the whole thing. I've watched James Tour's responses and even initial argument in your responses. I watched the whole thing. It was fascinating. But for the sake of the audience here today, could you just tell us his core argument and why it is false?
Yeah, I mean, well, number one would be I'm a synthetic organic chemist, therefore I should understand origin of life research the best. No, I spent 2 hours demonstrating that he's actually pretty clueless about all of the specific fields. It's an interdisciplinary field, and these people that are working on it, you need to understand geology. You need to understand aspects of astronomy. You need to understand a lot of different things, which he doesn't. He builds little nano cars, and that's great. That's very impressive. And if he was giving a lecture on nanocar synthesis, I'd go, great, you're an expert on that. Tell me about nanocar synthesis. But him pretending he knows what he's talking about with that field is a joke. So I spent a long time dismantling that. And the second one I talked about was homochirality, which is just about the chiral or handedness of biological molecules, and him pretending that that is impossible to arise spontaneously, which we know quite well is false, and we have actually a lot of ways. So I cited some research by Donna Blackman and some other people that show a multitude of ways by which chirality can. I mean, I won't bog you with the details. If anyone really wants to see that, go to my James Tour responses, and I talk for 20 minutes about that. Then the third thing I talked about was just he pretends that we have no idea how all these biomolecules could have come about, which again is false. There's a lot of research, Jack Shostak, John Sutherland, a lot of these guys showing very viable pathways to relevant biomolecules from universally available precursors, prebiotic precursors. And then the fourth thing, what did I say? It was about cells. I think he was just talking about what I said earlier about he just likes to show, just like any other creationist, look at this crazy stuff happening in this modern eukaryotic cell that took 4 billion years to evolve. How did that come together by chance? Well, it didn't. Nobody is saying it did, so stop. There's just a lot of stuff like that where, I don't know, like I remember one thing for carbohydrates, he was trying to talk about polysaccharides, right? And so in nature, so polysaccharides, for people who don't know, things like starch, right, glycogen, you've got little glucose monomers, and they go chink, 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 right? You got a long chain of glucose monomers, right? And so he's saying, well, how could that have, how could starch arise, naturally without, enzymes or anything like that? And in order to defend how difficult it is to synthesize polysaccharides, he goes for 40 minutes talking about industry, like laboratory polysaccharide syntheses that have nothing to do with natural products. He just takes a paper and is like, here's a polysaccharide. That's not a natural product. Yeah, it can get really complicated if you want it to be. You can make some crazy thing, and it's very complex. But this is the kind of duplicitousness. And then I also had to point out that, well, it's really no problem. You've got RNA, or you've got ribozymes. Those can generate polypeptides, and then boom, you've got enzymes that can generate polysaccharides. So biologically relevant polysaccharides never needed to be synthesized without the presence of enzymes. That's really all there's to it.
There's an analogy he brought, and I think as soon as I hear the analogy, I switch off. That the Boeing 747 and the storm, putting apart. Yeah. Oh my God! As soon as I hear this, I just go like, "Oh my! You're kidding me?"
You're not interested in scientific discourse if this is the kind of thing that you're putting
forward. And this is what really annoys me. I mean, I can understand you can hear this from the likes of
Kent Hovind and these guys.
Those people. But him, come on! I mean, he's like, come on, you're a scientist. You shouldn't be saying things like that.
That was what he led off with. I mean, when he put out the series, I was like, oh great, what's he going to talk about? And that was the first thing out of his mouth, and I was like, this is going to be ridiculous. And it was. Every single episode, I was like, oh my God. I mean, not just the bad arguments, but there are so many instances where it's just like, look, I caught you misquoting this person. You misquoted this person. You took you pasted this. You snipped something out. You're twisting these words. Like, it's just very, very blatant. It's undeniable that he's not just not understanding the science he doesn't want to understand. He's actively lying. He's actively misrepresenting the research he's representing, because he knows that his viewers, they don't have the faintest idea what he's talking about. It's it's another language to them. It's just gibberish to them. But he shows a paper, yammers about it, speaks very confidently, and everybody goes, yeah, they cheer for him. It's like, dude, he's everything out of this guy's mouth.
What's happening? He's choosing. Now his obviously scientific reputation is a risk here, because obviously the pure it's just he's going to have it, and he's going to end up with the cronies, those who just sort of watch and like and share without even understanding a word he's saying, and he's going to lose the respect of the actual scientific world. So
that happened a long time ago. He's definitely the laughing stock of the scientific community. But I mean, I mean, he seems to be transitioning to. I mean, he's an apologist now. I don't really know what he does in his lab. I know he has grad students that pump out research, but I mean, he seems to have made his choice quite clearly about being an apologist and not a scientist, at least not in this regard. So
he's even had some series with a Muslim dude, I think, and they were obviously they shared even though they probably be fighting elsewhere about the nature of God, whether he's three or one, the argument between Christianity and Islam, but they're united in the front here because they're together. They were talking about
any enemy of my enemy is my friend, right?
Exactly,
anybody who agrees that there has to be a God, doesn't matter which God, but God did all this.
I don't understand how this is emerged. Therefore, must be, and this is, I think, if there is one point down to the 5-part series, it's down to this. I don't understand how this has happened. Therefore, but in science, you can say you can start with the exact stance. I don't know how this has happened, and therefore, I'm going to go back into my lab and try to find out how it happened. Until then, the answer is, I don't know.
Or just wait a while. Somebody else will figure it out. Yeah, I mean, as I said way at the beginning of the conversation, the God of the Gaps argument is fundamentally flawed and useless. All you have to do is look at what we used to know or not know and what we know now. We used to think that a volcano was a god in there making the, smelt, doing the whatever, forging the sword or whatever, and all this stuff coming out. And we thought that lightning was Zeus and thrones. It's like, we used to not know anything. And all of it was gods. And then little by little, we figured stuff out. And we took this God of the Gaps. And now he's crammed in like, what do you call those? I can't think of the name. Those plants that you put them in a whatever. It doesn't matter. But he's kind of crammed in a little case in Origin of Life and Origin of the Universe. Those are the only two places where the God of the Gaps remains.
Shrink wrapped like a cappage somewhere.
So, bonsai, I think is the word. It doesn't matter. Whatever. It's just a fun little visual. But, and as far as I'm concerned, the God of the Gaps in Abiogenesis is on his last limbs. I mean, it's not really that ridiculous. The one at the beginning of the universe, I'm going to give him a while there to live. And I'm certainly not I'm not Lawrence Krauss. I don't know I know very little about Big Bang cosmology in a sophisticated way. But if somebody says to me, you know what, I think that there's a God because I think that there's a God that started the universe, and that makes sense to me, I'd go, well, fine. That doesn't bother me. There's no problem there. But when you start talking about, well, how did God made humans in our exact form and we look just like him coincidentally, this is like, come on, man.
Yeah, because you have actually an interesting movement that would actually say, I'm with you on all the science. Evolution, but my God, that's the way my God did it with the science, with evolution.
Yeah,
and I don't have a problem with that.
Me neither. Not a problem. I disagree, but I cannot can't prove you wrong. I cannot prove that there is no God. You know what I mean?
Yes.
And if you're just I forget the difference between deist and theist, but if you're whichever the one where you're just like, there's a God and like that's it, and everything else is the way science says it. No problem with me.
Yeah.
You go right ahead. Yeah.
Yeah. Well, Einstein was in a way, his God was Spinoza's God, which is not really a God. It's just
kind of not really God.
But he's probably was preparing the world psychologically for atheism, because I think the blow would have been too hefty.
Yeah.
So I think that's what Spinoza was doing as well. So I don't have a problem with that, if that's the case. But because that particular type of God does not require you to cut the edge of your penis and sacrifice a goat and this, that sort of thing.
Nor does it contradict anything that we turn up empirically. That's the main one for me. Well, the other one too. Yeah, I can't
exactly.
kill in the name of the deism.
And that's my issue right now, because these beliefs, people think beliefs have repercussions, they inform actions. So if you think like that and you are going to say, I'm not taking the vaccine because that's all rubbish, it's all bullshit, these bad beliefs turn into actions, and these actions can be quite ugly. And turn into, they can actually hurt someone who's completely innocent.
Yes, anti-science mentality has many facets, and wherever your entry point is, for many, it's indoctrination from religion, which causes them to reject science that contradicts their religious views, which then causes them to reject many other forms of science, like vaccines and things like that. Or if it's more of a conspiratorial, anti-establishment thing where you're like, oh, big pharma and government and all this stuff, and it causes you to just, in a blanket way, reject science. All of it is bad. All of it has negative repercussions on society. All of it has tangible ramifications that are quantitative in terms of death toll and things like that. We can really count the people that die because people don't subscribe to scientific principles, scientific worldview. And that, if anything, I would say is the closest thing I can think of to a purpose, is to, as a science communicator, try to bridge that gap, try to be somewhat of an ambassador for the scientific community, or I look at the general public, look at what they're believing, look at what they're saying, try to understand why they're saying it, try to explain to them the things that they're not getting in as best I can, yeah, I think that's why science communication is emerging as a really big field and a really big, career choice now, as of only the past few years. But it's looking more promising. It's a huge problem. We need a lot of people to be doing this thing that I'm doing and that many of my colleagues are doing. We need a lot of people doing it a lot of different ways. Everybody's going to have a different style. They're going to reach a different type of person. But we need a lot of people. We need it now, because I fear that we may not see the 22nd century if we don't get a grip on science denial and we don't get everybody on board with just a very basic, rudimentary scientific worldview.
Yeah. As we wrap this sort of chat up, I want to bring something that it seems to be a thing that is probably going to be a theme throughout all the 5 gaps. And I actually put it to Lawrence Krauss yesterday. The simulation hypothesis, because it takes care of the creation or the design part of things. Some of the things have been talked about, where the things are complex and it not arise by sort of coincidence, and that's their main argument, really. Is it conceivable that we are a simulation of our future us?
Of our future us? Oh, that's a twist. I mean, I was going to say it's certainly conceivable that we are in a simulation. You can conceive of it, and you can't disprove it. So,
yeah.
But
the future us is the
what do you
future
mean
us
by
is actually
future us?
it is part of the main. I think it was posed by a philosopher, and the future us is saying, why would an intelligent culture simulate us? And one of the responses was, it's actually us in the future, and we were completely divorced from our humble beginnings, and we're trying to roll the video back. It's a bit of nostalgia, and it's a bit of fact finding. They're trying to find out how they have started, and the only way to do it is to roll back. It's almost like what we do simulations. We do cosmological simulation.
Yeah.
We exactly do that. But instead of doing it in terms of cosmology or biology, they do that in terms of how they have evolved and let the video sort of roll. Could that be a possibility?
I don't know, man. Sounds cool to me. I mean, when you get this abstract, I mean, sure. I cannot say that it is impossible. I'm not equipped, certainly, with my knowledge set, nor do I think necessarily that anyone could conclusively say that something like that is certainly not the case. But yeah, those kinds of things. I mean, it's like, that's why thinking about the existence of a God, just any like a general divine entity, is just not that interesting to me. You know what I mean?
Yeah.
Like, I definitely want to address people who are like, there's a God and it's exactly like this, and he looks like this, and he says this, and this is what he wants, and this is what he thinks about all you people. Well, no, get out of here. You're wrong for sure. But just the pure notion of a divine entity, I don't even like, what's the point of even thinking about it? You know what I mean? Like, it's just so, I'm just going to focus on learning what is feasible to know, you know? And so this falls into the same category with me. I'll almost certainly die not knowing not being one iota closer to knowing whether this is a simulation or not. So why bother thinking about it? You know what I mean?
Yeah. There's a new movie's out by the guy who I can't remember his name now, from Deadpool. It's called Mr. Guy.
Oh, the Ryan Reynolds. He's in a video
Ryan
game.
Reynolds. Yeah, apparently it's quite. I want to watch that because they say the simulators. Obviously, you will never find out. If you've been simulated, there are strict rules. One of the very funny thing is the speed of light. Why the speed of light is constant. And the theory is going because there's something called just-in-time simulation. So you can't simulate so much data because the system will not be able to handle it. So you simulate as you go. So you imagine somebody's digging a hole, it gets simulated as you go. And the speed of light is the barrier between you finding out, because if you pass the speed of light, you'll find out who your simulators are.
You get to the edge of the simulation. Yeah. My favorite video, I think it's from like the 90s or something, but there's a movie called the 13th Floor, I think it was called.
Yes, of course.
That is a good one. I really like that one in terms of simulations. If anyone hasn't seen that, I highly recommend it.
It was around the time of the big, the Matrix and all these kind of and this one fell under the radar. It's not very well.
Most people I talk to don't know about it, but it's a good one. I like it.
Yeah. Look, I mean, it's an interesting thing, but as you said, it's very difficult. Maybe we have a finite life, and we need to be wise about how we're going to spend it. You can spend it in crazy endeavors like that. That's going to be futile at the end. Or you can change a thing or two by getting engaged. I
mean, it's fun to like get stoned and think about for a while, but it's not like it's not going to be the focal point of my existence. Trying to crack the code. I'm gonna figure it out. If it's no, I'm not. Just stop it. Stop it. Enjoy your family. Enjoy your life. Try to learn some stuff. Try to do some good. That's about it.
Would you take the red pill or the blue pill?
Yeah, I'd take the red pill.
Yeah. Okay. Fair enough. You won't enjoy the steak scene where the guy was knowing the steak doesn't exist, but he was enjoying it anyway.
I mean, ultimately, I want to know, and ultimately, that's the thing that saddens me the most about death and finitude. I'm very okay with ceasing to exist. That part's fine. I would not want to exist infinitely, and I think anybody who does hasn't really thought about it very hard, because it would be torture, and I would like to stop existing at some point, probably a little later than I eventually will, but whatever. Finitude is fine with me. It's the not knowing. I want to know what happens in the next century, in the next millennium, in the next billion year. I want to know. I want to see it. I want to know what's going to happen. And
but you see, Dave, I'm exactly like you. But I came to realize that when you cease to exist, the emerging property of curiosity will also evaporate. So
that's true.
That will go away too.
You're right about that. So I'll be fine. I'll be just fine.
It's because we always think about death is we existing outside ourselves, watching us not existing.
Yeah. Oh man, this is boring. I can't do anything now. I don't have a body.
This is incredible. Look, I've thoroughly enjoyed this. I think it's been a brilliant chat, and I hope that I can chat with you again in the future.
Sure.
But this has been brilliant, and this is very promising. A lot of the three other parts, I think people have to fill in big shoes between you and Professor Lawrence Krauss. I think you've done the first two parts of real justice, and I really thank you so much for not just today but for your efforts and your brilliant channel. Over 1.5 million subscribers.
That would be something.
That would have been some interesting prospect there.
Yeah.
But I watch your channel quite frequently. As soon as I've got the bell, as soon as a new episode is up, I definitely got to watch it, because within 7 or 8 minutes you crack the code. You get it. It's there. It's easy, and I love your visual aids as well, and the comprehension question towards the end. I make sure that I always pose and solve.
Very good. Yeah. See, give a little test. Did you get it?
Mm-hmm. Yeah. So, you have any final comments before we end today?
No, not really. Yeah, thanks for having me on. This is it's a topic that I enjoy discussing. I mean, I enjoy talking about all kinds of, all sorts of topics in this general area. But I'm especially happy to talk about abiogenesis a bit more now that I went ahead and was prompted to look into the field quite a bit more and correspond with some of the people in it. So I feel it seems that there's not that many people that are eager to talk about this, other than the researchers themselves, who kind of prefer to just do their work. So I'm happy to try to be the liaison on on their behalf as best I can.
Well, thank you very much, Dave. Do you have any future projects that you're working on you want to tell us about, or is there any interesting series you're starting?
Yeah, just working real hard on the channel. I mean, I pretty soon I'm gonna have zoology coming out, psychology is coming out, but yeah, more physics, more chemistry, more everything. Just trying to do it all, trying to cover everything.
This is fantastic. Well, thanks everybody for tuning in today. In the next, I think next week, it's going to be the third part, tackling the problem of consciousness with Dr. Richard Carrier. I'd like to thank my guest one more time, Dave. I wish you a great day.
You as well. Thanks a lot.
Thanks very much. Goodbye, everyone.